look at another worked example, and this one where they're not stuck together. We've got a 100 gram marble which strikes a 25 gram marble. So once again, choose positive direction to be to the right, and the momentum of the large marble beforehand then is 0.1 times 1. 0.1 is 100 grams divided by 1,000, giving you 0.1. The other one isn't moving, so total momentum before is 0.1 kilogram meters per second. Looking at after the collision, then we know that the larger marble is moving at 0.6 meters per second, and we need to work out then the velocity of the other one. So we just call that v, or unknown, at this point. And we have that the red marble here, 0.1 times 0.6, that gives you 0.06 kilogram meters per second, which appears down there. And the other marble, 25 grams, 0.025 kilograms, multiplied by our unknown v. So its momentum is 0.025 times v. So once again, we can use the concept that total momentum before is equal to total momentum after, and we make that clear in our statement that momentum is conserved during the collision. And then we just set both sides equal to each other, rearrange to get v, and make a clear statement of the direction of v. It is useful to do before and after diagrams with all the masses and the velocities represented on it, and particularly the directions of the velocities with the arrows to help keep that bit right.